This video I'll give you explanation of every single scenario. Before I give you all 10 scenario, I want you to have your pen and paper ready and write it down. Number 1, allow us to understand the static electricity using a Van de Graaff generator. Van de Graaff generator is a machine invented by MIT physicist in 1929. Static electricity is imbalance of electric charges on the surface of a material, and you will see that on Van de Graaff generator. Scenario number 2 and 3 uses electroscope to help you understand difference between induction and conduction. Scenario number 4, 5, and 6 allow you to understand the difference between neutral and negative and positive charges material. Scenario number 7 and 8 allow you to understand how insulator different than a conductor. And scenario number 9 and 10 investigate the behavior of insulator and conductor upon adding electrons. For example, if you throw some electron in insulator and in conductor, and it allow you to see what the electron do inside the insulator and inside the conductor. So let's get started. First one is Van de Graaff generator. If you remove the top of the Van de Graaff, what do you see? You see two rollers, one on the top and one on the bottom, and there is a belt sitting on the roller. And if you turn on the motor, belt will start spinning. It's spinning so fast that the comb sitting on the top will block all the electrons, making the top of the Van de Graaff generator positively charged. Now, if someone like this boy touched the Van de Graaff, what happened? All the electrons from his body move to his hand and transfer to the Van de Graaff, making his body
positively charged. Now how would he know his body is positively charged? Is because look at his hair standing up. Is because this hair and that hair and that hair, the hair next to that one is all positively charged and started repelling each other.
When I bring a rod that is positively charged near the knob, all the negative charges of the electroscope move to the knob, making the leaves. You can think as if leaves are two here. Leaves are making the leaves positively charged, so they repel each other. But when you remove the rod, you see they go back to normal. It's because the electroscope become neutral again. Now scenario number 3, same thing, but this time you're touching. This is called, you do a positively charged rod, you touch it on the knob. And what happens if you touch it on the knob? All the electrons move to the positively charged knob, as many as possible, not all.
It's possible, making the
rod neutral, however, making the electroscope positively charged. So that's why leaves repel each other. But when you remove the rod, what happens? It's still those leaves repel each other. Scenario number 4, you see that there are same number of electron and proton. That means the object is neutrally charged.
There are more electrons than protons, meaning that the object is negatively charged. Scenario number 6, you see there are more protons than electrons, meaning that the object is positively charged.
The electrons cannot move. They barely can move. Electrons are not free. They cannot move freely. What does that mean? That means this is an example of insulator.
That electron can move freely. What does that mean? That means that electrons are inside the conductor. Investigate the behavior of insulator by adding some electron. If you add some electron, what do you see? Electron cannot move. If you add them on the left, they confined in the left. They cannot move to the right. You do the same thing. You add electron, but what do you see? Even if you add the electron to the left side, they move to the right side.